Hello, so in this course assignment, I have chosen to work with a multiple regression analysis, and I had to pick two different models of multiple regression analysis. I have a set of independent variables and one dependent variables which are trying to predict based on the assignment itself. So we have four potential independent variables, which is temperature represented by AT in here. We have AP, which stands for ambient pressure. We have V, which stands for vacuum. That's the third independent variable. And we have RH, which stands for relative humidity. And the variable we are trying to predict is the power electrical energy output. Electrical energy, essentially. So what are the two models I have chosen to use in this multiple regression analysis? So I've built a model with two independent variables, basically the temperature and the vacuum. And my dependent variable is the energy output. And in my second model, I'm using the four independent variables: temperature, vacuum, ambient pressure, and the RH, which stands for relative humidity. So these four are being used as independent variables. And again, we're still trying to predict the net hourly electrical energy output as represented here by PE. In both of the models, I have used 9,499 observations, and the last 20 observations at the very bottom of the file we're using as a validation set. So in this first model, when I only consider temperature and vacuum, I can see that my R square, which determines and says that the variance observed in PE in our dependent variable is explained by temperature and vacuum. So that's a pretty high R square of 91.57%. So all the variance in the electrical energy output, 91.57% of these variance can be explained by temperature and vacuum here in the R square. Then we have the coefficients, intercept, which is basically which value energy output assumes when temperature and vacuum are null. It's 505.49. And the coefficients for temperatures minus 1.7 and vacuum minus 0.32, which basically says it's an inverse relationship. So the higher the temperature, the higher the vacuum, the less electrical output I will have. And now I've took, so if I go all the way down, I have, my last observation. So I took this last observation and have pasted in here. So which value is predicted for electrical output when I have a temperature of 21.6 degrees Celsius and a vacuum of 62.52? What is my prediction for electrical power? So according to this model, my prediction would be 448.38. And the actual value, which is inserted in the last row of this file, is 453.28, which gives us the residual. The residual is the subtraction of the actual electrical energy that I got minus the prediction of my model. So the residual is 4.89 approximately. The same observation when used in my second model, which has a slightly higher R square. So the prediction is a little bit closer than the actual power energy. So we can say the second model is better than the first one.